Paul Cher is a researcher who, together with his colleague Emil, found vulnerabilities in FFmpeg. He then wrote me an email asking if I would like to make a video with him. And this led to the very first LiveOverflow podcast episode, which you should listen to get a bit more context for this video. So Paul will now walk us through some of his exploit process, and I will add some comments here and there to hopefully make it a bit easier to understand.
Hello everyone, my name is Paul, and today I will be presenting you guys the research about FFmpeg security made by me and my colleague Emil Lerner. We have already presented it in our talk on Pitch Days conference which took place in Moscow earlier this year. I believe you can still watch it in the recording. We didn't cover binary exploitation too much in our talk, so today we're gonna focus on binary exploitation and go as much in depth as possible. But before diving into the binary exploitation, let's take a quick look what is FFmpeg and how it really works. FFmpeg is powerful open source software which allows you to easily record, convert and stream audio and video. Thus, it is used by many platforms and services that provide file storage, conversion and editing functionality. This really means that FFmpeg is used almost everywhere, starting from your favorite messenger, finishing up with your lovely meme storage.
When you upload a short video as a GIF or so on some image sharing platform, it's very likely that the video is handled by FFmpeg. It's really a very popular and big tool.
Of course, such system would be a good target, because it has very large attack surface. There are some really cool researches already. For example, research presented at Black Hat 2016 by Maxim Andreev and Nikola Yermishkin, or research by Jean-Val Conveld and Mateusz Jurczyk from Google, who managed to fix thousands of bugs in FFmpeg, and many other researches. Knowing this, me and my colleague Emil still tried to take this challenge and find some new bugs. First, let's take a quick look at the FFmpeg functionality. FFmpeg has really cool features, and all of them are described in the documentation on their official website. Seems like there is a feature that allows you to collect files not only from the local file system, but also from the remote systems by using networking protocols. So, as you can see, you can provide a link as an option to FFmpeg, and it will go for the remote file and take it and process it. Let's download the source code from their GitHub and see how this process is implemented. And now I'm going to clone the repo to my Ubuntu virtual machine. And this actually may take a while. So, now we have downloaded the FFmpeg source code. To follow my next steps, you will need to be sure that you have downgraded your FFmpeg to the vulnerable version. You can do it by resetting your FFmpeg to correct version by using the commit number or by grabbing it from the git log, as I do it right now. So I'm using git reset hard to pull the head directly to the exact commit number.
That's a funny little advice. Look through the git commit log with his name in it to find the latest version before it was fixed.
Now let's take a quick look at the HTTP protocol implementation. I'm using Vim to do this. So as you can see, the FFmpeg doesn't use the libcurl or any other library, and it has the custom implementation of the HTTP protocol and also many others. So it is really a good surface to search for the vulnerabilities.
And this is a very important observation. libcurl has been audited and is around for a long time. It's a very safe library and also used a lot. But instead of relying on some other library, FFmpeg implements its own HTTP handling. And sure, you will think that HTTP is very simple, but there are weird protocol features that can break your neck when you actually have to implement it in C.
So, for now I have two versions of FFmpeg compiled. The first one is compiled with AddressSanitizer. We talked about this one in our podcast. And the second one is the original FFmpeg binary, but it has debug symbols and it is compiled without code optimization options. So I can easily debug it. You can do it as well by configuring project with the following options.
I just want to quickly explain the basic idea behind AddressSanitizer and why it's great for debugging, but also for finding heap vulnerabilities. For example, one feature is that ASAN will automatically fill certain memory areas with a recognizable pattern. And when then some code uses bad memory, for example in a heap overflow case, it will likely crash because of those values. And you can easily recognize that it crashed because it read data from that memory. And there are a few more ideas and tricks like that, so it's very convenient.
So let's quickly recap how we actually did the fuzzing. At some point we thought that there might be a small chance that nobody has been fuzzing the network protocols in FFmpeg before us. So we might find here some vulnerabilities. And yeah, this was exactly the case. I won't explain too much about the fuzzing process because we used secret, complex, dark magic related technique called launching, AFL, and the process of fuzzing was already described in the podcast, so let's jump directly to the part where we already have a crash. So, here I got my crashes. I have already simplified them a bit to be more readable for you, so let's take a quick look at them first. So, the first one is ASCII text, basically. Let's open it with my favorite, Vim. So, this is HTTP protocol. It has a lot of really interesting features, like transfer encoding chunked, for example, which was used here. Basically what it does is, instead of setting the content length header and length of data and the whole bunch of data afterwards, it allows you to send the data to server in little chunks. First you send the size of the chunk in hex, and then the next line in the chunk itself, finished with the serial F. And there -1 was used as a size, as you can see. Maybe this was causing an issue, so let's move on. So here I wrote a simple echo server. Basically what it does is it is binding on the port, listens for everyone, and it is basically reading the argv1 file name. It reads it and basically echoes to the output, so nothing too much special. Let's now launch both binaries with this output and see what happens. So let's launch the original binary first. Segmentation fault confirmed.
So he wrote a small server that just responds with the test case that causes a crash and pointed FFmpeg to load the file from there. And then it caused a segmentation fault. But how do you figure out now where and why it happened? And that's why he compiled a second version of FFmpeg with AddressSanitizer instrumentation included.
So for a more detailed report, we now are launching the AddressSanitizer binary. Let's see. So the heap buffer overflow in function HTTP buff read. This is nice.
You can see here the output of AddressSanitizer, and it recognized a heap buffer overflow. And it shows you here how the heap looked like, and FA means heap red zone. So that's a bad address, and because it was also compiled with debug symbols, you can easily see the trace of functions.
So let's launch FFmpeg using GDB and take a closer look at what happens. And then we will start auditing the source code. So as you can see, the server is already launched. Let's connect to it using FFmpeg and GDB. So, as you can see, the crash is actually caused by memcpy because it reached the end of a mapped virtual memory region. Let's look at the backtrace. So, in these functions, it seems that the size equals to -1 integer.
So, being able to pass in a negative chunk size is clearly a programming mistake that apparently leads to an exploitable condition.
These two functions are very interesting. Let's look at them. Once again, I will be using Vim as my IDE with support of C tags. This will allow me to navigate through the source code quite quickly, so keep up.
Just FYI, C-tags is a tool that will sift through your code, indexing methods, classes, variables, and other identifiers, and will store them. And Vim can then use it to quickly jump around in the C source code. So Paul now investigates a bit around the line that caused the crash.
So this is the HTTP buff read function, and inside the memcpy the len is actually -1 over here. So this is actually not exploitable, but let's look at what caused the corruption of the size parameter. This was already corrupted in the previous function which called it. So let's look at it. This is HTTP readStream function. It is actually in the same file. So let's scroll up to the top of the function. Okay, as you can see, there is the piece of code which corresponds for the reading HTTP chunk data. So there is the line reading, there is the strtoll function, which also accepts the negative numbers. So the chunk size could have been negative, and later the minimum was taken of these two, and of course the negative number was less than any positive. So that's probably how our size integer was corrupted, which caused the crash of FFmpeg.
So str to long integer is a function that converts a string to an integer, and integers can be negative, and we know that the HTTP chunk size was set to -1. So this function will return -1, and a memcpy with -1 is nonsensical.
And later there is the HTTP buffstream function which was called with the negative argument. So, as you can see, this is actually not quite exploitable. Let's jump back to it. And but still, if we will be able to fall through this branch, meaning that buff end will be equal to the buff pair, we will be able to call FFurl read function, which is different from the memcpy. Let's look inside it. And this is basically calling the retry transfer wrapper with the callback, which is called URL read. So here it is code, and URL read is basically a function which accepts some parameters. It fills this parameter to the read function and calls it. So that's it. Maybe we will be able to translate -1 to the read function, and this issue will be actually exploitable.
Oh, stop. Oh boy. Now I'm completely lost. I didn't understand that last part. But that's because we don't know enough yet about the heap and some other structures. As you can see, this video is getting a bit long. It's a lot to process already. Let's continue this very technical part in the next video and see if we can understand it then.